Hi, in this video we're going to show you a short demonstration on creating an additive synthesizer. Now the theory behind an additive synth is that it adds together sine waves at different frequencies and different amplitudes, and typically can be used to create sort of organ type sounds. So I'm just going to quickly go through setting up a additive synth. I'm going to go a bit faster than I did in the previous video, so I would recommend that you look at the sine synth videos beforehand. So to create a synthesizer that responds to MIDI input, I need to create a MIDI in object, and what this does, I spelled that wrong, a MIDI in object, and what this does is it receives any MIDI data that's received from my keyboard. I've got a MIDI keyboard connected to this computer, and outputs on here. So if I then use a X note in object, what this does is it interprets MIDI notes and allows us to see the information that we're actually using. So I output my MIDI in object and the output of that, so all the MIDI information goes into my X note in object. What the X note in does is it splits the MIDI information into pitch, into velocity, into note-ons, and then into channel. And really, just for doing a simple synth, we're more interested in the pitch and we're interested in the note-on, note-off. So the pitch, MIDI pitch, will actually be, I'll do a number, will actually be a number between 0 and 127. So if I press a MIDI note on my keyboard, it gives us the responding number on here. And if I wanted to create a oscillator which works upon that, I need some way of converting between that number and a frequency value. And in Max MSP we have the MTOF operator, so which converts. And so if I output, so this is the MIDI note number pressed, and if I do another number box here, we will see that it then converts between that number. So MIDI key 43 is 93 Hertz. So for an example, MIDI key 60 is 261 Hertz. So I could connect that up to a cycle object, which is a oscillator which outputs a sine wave, and it's actually cycle squiggle. It outputs a sine wave at the frequency that is sent to it. So just sort of rearranging this, because so it sort of makes a bit more sort of gives us a bit more room. And the other thing that we need from our X note in is an on and off. So our synth sort of responds to on and off messages from that. So we've got on and off here. So if I press a note, it goes on there. We're not hearing anything because we haven't actually connected this to our audio system, which is EZ DAC. So if I connect our cycle to here, then we've got our input. So if I disconnect that, and if you remember from the previous video, if we have a multiply squiggle object, that allows us to multiply this output stream by, if we connect this to our note out, if this input by a 1, that outputs a stream. If it multiplies everything by 0, then that gives us silence. So I can use a note on and off to output either a tone or a knot. So if I lock that and press a key, that's key number 45, that's converted to 110, and then so our cycle oscillator starts operating at 110 Hertz. When I press a key down, that causes a 1 to happen there, and so that multiplies every sample by 1, which was the same. So input is equal to output, and when I let go, that changed to 0, which is a note off received, and then that multiplies. Cycle oscillator is still oscillating, but it's being multiplied by 0, so it's output in silence. So that's a basic structure of our sine oscillator. Now, if I want to have several sine waves, we'll just sort of rearrange this to sort of help us. I need several cycle oscillators. So if I control and paste this, so now I've got 2. We'll do this with 4. So it just creates 4 cycle oscillators, because we are going to be adding 4 sine waves together. Now, when I press a key, this causes a MIDI note to be stored there, which is converted to frequency. What I might want my synth to work on is harmonics of that. So the way that we can do this is if we multiply this number by 2, 3, 4, 5, etc., which will give us the harmonics. So I've got our first frequency is at 110. I might want the second one at 220, 330, etc. And we can do this by using the multiply object again. So if I create a new object in here, and it's just to multiply 2 numbers, not 2 signals. So if I put this one there, and I would now multiply this number by, multiply that by 2, and I'll put the result in here. So if I connect this up to there, and then connect this one to here, now we have 2 oscillators, and if I press a key, this first one is outputting a tone at 110, and then this second one that's multiplied by 2 to give us 220. So if I was to attach that to there, we get a richer harmonic signal happening. So if I carry on with this, so if I copy, we'll get rid of these 2 cycles to make it easier. So if I copy those and then oops, should have moved it before. So all I've done here is I've just copied and pasted these 3 cycles, and we'll change the number. So multiply that by 4, and then multiply that by this would 8, and then we shall just route the original input frequency into these ones. I'll just move this around to make it a little bit more obvious what we're actually doing. So our MIDI information is received there, goes into note in, which will give us a note number, and then when I press that number, it converts that note number to a frequency. So our first cycle oscillator works at 97 Hertz. It multiplies that number by 2, which gives us 194, times by 4 gives us 388, and times by 8 gives us 766. Move this one slightly out of the way there. So if I route all of these to our input point here, if I route several signals to the same point, they are actually mixed. So now I've got 4 oscillators which are controlled by a MIDI note, and then we simply multiply this frequency by others to give us a more harmonic symbol. So if I press a key, that gives us a kind of an organ type sound. So that basically is mixing together different frequencies, but something a little bit more useful would be to change the actual amplitude of each one. So if I get rid of these roots here, and we'll move this sort of around. And move that from there. Now, if we use gain object, this will allow us to change the amplitude of each of these cycles, oscillators, separately. So what I'm doing is I'm routing it through this gain object, and I'm going to move this one sort of down here, and we'll create one of these for each of our oscillators. And then we'll route the cycle to its own gain command, gain controller. There we go. And then we'll route the output of these gains into our stream there. It's a bit fiddly on there. So now I've got some faders which control the relative amplitude of each note. So now if I sort of put these as various things, I could control the harmonic content of this oscillator. So if I go, this basically additive synthesis is quite good for doing kind of organ type sounds like this. So one of the things that you can do is you could change the numbers which are actually here as well. So you could change this, try this to 3, and this will give you a very different sounding type synthesizer than before. So if I move this up, so this has got quite a lot of control over the actual harmonics by changing these numbers, and we've got control over the sort of synths, actual amplitudes by using these gain objects there. So that's a simple additive synthesizer.